Okie dokie, welcome back. Let's take a look at example 3, letter B, which is x minus 8 plus 7x squared. So if you notice, actually, right off the bat, this one is kind of different than all the other ones. And the reason for that is it's not a standard form. So what I might do, and I would absolutely suggest that you do, is if you come across a weird looking one like this, put it in standard form first, because otherwise doing all these up here is going to be a little more challenging than you would like it, okay? So in standard form, we'd have our x squared stuff first, so 7x squared. Then we'd have our x stuff, so plus x, and then would come 8, so minus 8 here. Okay. So now that looks a little bit better. Let's go ahead and check for GCFs. 7, 1, and 8, x squared, x, and nothing, so no GCF here. Special pattern, square root of 7, no way. So we are left with guess and check only. So let's go ahead and set up our polynomials here. So the first thing I need to get 7x squared. So the only factors of 7 are 7 and 1. So let's do 7x and 1x. Now with 8 I have choices. Now they have to have a difference of 1 here because that's the coefficient on that guy. So let's think here. Actually, let's do 2 and 4 because that's where I usually start. So 2 and 4. Then without even putting signs in here, we do 7x times 4, which is 28x, and then 2x here. That's going to make 26x or 30x. That's not going to work for us. So let's get rid of those. So 2 and 4. Now, might I want to switch them? Well, that's a possibility. So let's switch the 2 and the 4 before we totally get rid of them. So let's do 4 here, 2 here. So 7 times 2 is 14. 4 times x is 4. So we could either get 10 or we could get 18, neither of which is 1, so those aren't going to work either. So now we can officially get rid of 4 and 2. The only other factors of 8 are 1 and 8. And like I said, you're not going to use those often, but you will use them. So let's think here. If I put 1, then 8, and then I would have 7 times 8, which is 56, and 1, oh, that's not going to work. So get rid of those. Let's just switch their spots. So let's put 8 here and 1 here. So now we do 7x times 1. 8 times x is going to be 8x and 7x. I could totally get 1 out of that. So now this being a negative, I need alternating signs. So alternating signs. So I need 1 plus and 1 minus. And my middle term needs to be plus, which means my bigger thing down here needs to match that. So 8 is going to be my bigger thing. So this should be plus minus. Let's FOIL to check. 7x times x is 7x squared. 7 times negative 1 is a negative 7x. 8 times x is a positive 8x. 8 times negative 1, negative 8. And then we combine like terms right here. So we have 7x squared. Negative 7x plus 8x is indeed a positive x minus 8, which is what we started with. And there we have it. We have our two binomials, neither of which can factor further, so we are done with this one. Alrighty, letters C and D, same thing here. So we're still A checking for GCF. B, I guess, checking for a special pattern. And then C, then going to guess and check. Okay, so GCF 3, 11, and 14. No. X squared, x, and nothing. No. Special pattern, square root of 3. No. Okay, guess and check it is. So we have two binomials. For our first term, we have 3x squared, so our only options here are 3x and 1x. And then for 14, let's see, we have factors of 14 are 1 and 14, and 2 and 7. So let's do 2 and 7. Now you might be getting smart here, and like before you even write them down, start thinking of, okay, if I put the 2 here and the 7 here, well, we'd have 3 times 7, which is 21, and then 2 times 1, which is only 2. That's not going to make 11. So let's do the 7 here and the 2 here, and see if we can get 11 that way. So 3x times 2 is a 6x. 7 times x is 7x. So 6 and 7, again, not going to make 11 here. So those are actually out because I mentally tried the other way. So let's get rid of those. All right. Also, you don't need to write this one here if you don't like it. So if you didn't have that on yours, that's fine. If you do have it and you do like it, then keep it. Okay. So let's do 1 and 14. And you might be thinking, let's put 14 here and 1 here, because I know that's probably going to make 11 versus the other way around, because 3 times 14 is a rather large number. So then we do 3 times 1, which is 3x, and then 14 times x is 14x. I can absolutely make 11 out of that. This tells me I need alternating signs. This tells me that my bigger one needs to be negative, so the bigger one's obviously 14, so negative there, positive here. Let's FOIL just to be sure. 3x times x, 3x squared. 3x times 1, positive 3x. Negative 14 times x, negative 14x. Negative 14 times 1, negative 14. Then we combine these two guys, and we get 3x squared plus 3x minus 14x is a negative 11x minus 14. Bingo. And these are done. Cool. Alrighty. GCF, special products, guess and check. Here we go. Is it in order? Yes. GCF, 25 and 49? No. Special product, can I square root 25? Yep. Can I square root 49? Yep. So I might be in business here. So let's set up our binomials. We would have, if I square root 25, I'd get 5x for each of these. Remember, these you fill them in both spots here. If I square root 49, I get 7. So 7 here, 7 here. I don't have a middle term. Remember, that means I need 1 plus and 1 minus. So we should be good here, but let's just FOIL back out just to be sure. 5x times 5x is 25x squared. 5x times a negative 7 is a negative 35x. 7 times 5x is a positive 35x. 7 times negative 7 is a negative 49. These cancel, so I get 25x squared minus 49. Bingo. We're in business here, people. Alrighty, example 4 says factor the following polynomials completely. So again, we're still following GCF first, then special patterns, then guess and check. So let's go ahead and get rolling here. GCF, x to the fourth, x cubed, and x squared. I can absolutely remember the smallest degree here can come out, so an x squared is coming out. If I had 4 x's, I took 2. That means I have 2 left over. Plus 8, our coefficients are staying the same here. I had 3 x's, I took 2. That means I have 1 left over. And then minus 20. And then I had 2 x's, took 2, so I don't have any left over. Okay? So we did the GCF in this one. Now, that doesn't mean that you are done here, because look at this guy is perfectly set up to keep going. I still have a quadratic trinomial, and that's what a lot of these are. So let's check special patterns. Can I square root this x squared? Sure. Can I square root 20? Not a chance. So no special pattern. Let's try guess and check. Now this x squared has already been dealt with, so this is just hanging out on the outside. Everything else is going to come from in here, and that's what I need to deal with. Okay? So to get x squared here, I need an x here and an x here. And then I need factors of 20 that have a difference of 8. To me, those are going to be 2 and 10. And let's see, alternating signs. This is positive, so my bigger one needs to be positive, so that should work for me. But let's just double check. Keeping the x squared on the outside. X times x is x squared. X times 10, 10x. Negative 2 times x, negative 2x. Negative 2 times positive 10 is negative 20. So we get x squared times the quantity, x squared, and then this becomes positive 8x, and then minus 20. So if we mentally then do this, we get x to the fourth, and then this would be x cubed, and then this would be x squared. So I would get back to my beginning thing immediately. So we actually do have this as our answer. It worked out for us. And notice I didn't stop at just GCF. I factored out a GCF, but then this was able to factor further. So that's when you want to do it. So sometimes you're going to be doing 2 types of factorization in these problems, or maybe sometimes even 3. Okay, let's take a look at letter B here. B says 2a squared b minus 18ab plus 28b. Now the a's and the b's, actually a's, no, but b's, there's a b in each of them, so I can pull a b out. Is that all though? Well, notice these are all even numbers, so I can actually pull a 2 out. So we're actually going to pull out a 2b out of this one. Then we have 2 divided by 2, which is 1. And then we took this b, so all I'm left with in this guy is a squared. And then minus, and then 18 divided by 2 is 9. We took the b, so I'm only left with the 8 as far as my variables go. Here's a plus, so then 28 divided by 2 is going to be 14, and we had the b, and we took it, so there's no variable left on this guy. Okay, so we did GCF. Now looking in here, we have a quadratic trinomial. This is probably going to factor further. Can I use special patterns in order to do so? Can I square root a squared? Sure. Can I square root 14? Nope, so no special pattern. So then that leaves me with guess and check again. So again, the 2b just kind of hangs out front. And then I make my two binomials out of what's in here. So a squared, the only way I can get that is a and a. Then I need factors of 14 to add to 9. Well, that would be 2 and 7 in my book. Now I need the same signs because this is positive, but they both need to be negative because of that middle term. So let's try this. Let's FOIL it back out. 2b's hanging out outside. A times a is a squared. A times a negative 7 is negative 7a. Negative 2 times a is a negative 2a. Negative 2 times negative 7 is a positive 14. Combining my two middle terms here, we get 2b on the outside. A squared, boom ching, would be a negative 9a plus 14. And then if I mentally throw this back in, I would get to what I started with in the beginning. So this is our answer. And notice again, we had to do two different types of factoring in order to get here. So don't just stop because you factored a GCF out. Most of the time, now that we're getting to the more complicated factoring problems, you're going to be able to pull a GCF out and then maybe use a special pattern, or pull a GCF out and maybe use guess and check. So don't just stop at the first thing you do. Okay? Okay. Now, like I said, the more and more of these that you actually do, the better you will be. So I have a couple for you guys to try. It says factor the following polynomials completely. And I just have the two for you to try, so give them your very, very, very best shot. Don't just stop with the first type of factoring that you do. See if you can take it any further. And if you need to go back and rewatch some of the examples I just did before you do these, that might be a good idea. Please make sure you get these done before class so that I can check them. Thank you and have a nice evening.